Good day, everyone. Today we're going to talk about the linear algebra, chapter 2. I am Carla Joyce Puno and I am assigned to answer the number 23 on the chapter 2 exercises 2.4 about the matrices. Let's solve it. Chapter 2 exercises 2.4, number 23. Find the inverse of a matrix using elementary matrices. Our given matrix is a 3 by 3 matrix. We have 1, 0, negative 1, 0, 6, negative 1, 0, 0, 4. The first thing that we are going to do is to solve the given matrix to reduce row echelon form using elementary row operations. This will be our given matrix, and this is the identity form of the 3 by 3 matrix. The first step is to multiply 1/6 to the row 2 to get new row 2. We do this to the both matrix. So we have 1/6 times 0, 6, negative 1 equals 0, 1, negative 1/6. This will be our new row 2 for the given matrix. So we have 0, 1, negative 1/6. Next is 1/6 multiplied the second row of identity matrix. We have 1/6 times 0, 1, 0 equals 0, 1, 6, 0. We label it as E1. The next step is to multiply 1/4 to the row 3 to get a new row 3. So we have 1/4 times 0, 0, 4 equals 0, 0, 1. This will be our new row 3. We have 0, 0, 1. And then from the identity matrix, we multiply the third row to 1/4 to get a new third row. So we have 0, 0, 1/4, and we label it as E2. The next step is row 1 plus row 3 to get a new row 1. From the given matrix, we have 1, 0, negative 1 plus 0, 0, 1 equals 1, 0, 0. This will be our new row 1. And from the identity matrix, we add the row 1 and row 3 to get a new row 1. We are going to have 1, 0, 1. And we call this matrix as E3. The next step is row 2 plus 1/6 times row 3 to get a new row 2. We multiply the row 3 to 1/6. We have 1/6 times 0, 0, 1 equals 0, 0, 1, 6. And then we add it to the row 2. We have 0, 0, 1, 6 plus 0, 1, negative 1, 6 equals 0, 1, 0. This will be our new row 2. We have 0, 1, 0. And we do this to the identity matrix. We multiply row 3 with 1/6 and then add to the row 2 to get a new row 2. And we are going to have 0, 1, and 1, 6 as a new row 2. And we label it as E4. As you can see on the given matrix, it became a identity matrix or in a reduced row echelon form. We have 1, 0, 0, 0, 1, 0, 0, 0, 1. Now, we focus on the elementary matrices that we got. We multiply all the elementary matrix that we got, which are the E1, E2, E3, and E4. These are the elementary matrices that we got. We multiply all the elementary matrices to solve for the A inverse, which the number 23 is looking for. Now we solve for the inverse of a matrix using the elementary matrices. And our formula for this is A inverse equals E sub 4 times E sub 3 times E sub 2 and times E sub 1. We multiply all the elementary matrices that we got. First, we multiply the e sub 2 and the e sub 1. E sub 2 times the e sub 1 equals, we have a 3 by 3 matrix. We have 1, 0, 0, 0, 1, 6, 0, 0, 0, 1, 4. This is our e sub 2 times e sub 1 matrix. Next is e sub 3 times the product of e sub 2 and e sub 1, or the product, the matrix, what we got earlier. We have e sub 3 times the product of e sub 2 and e sub 1. We now have the matrix of e sub 3 times the e sub 2 times the e sub 1. We have 1, 0, 1, 4, 0, 1, 6, 0, 0, 0, 1, 4. This is our matrix e sub 3, e sub 2, and e sub 1. And lastly, e sub 4 times the product of e sub 3, e sub 2, and e sub 1, or the matrix that we got earlier. E sub 4 times the matrix of e sub 3, e sub 2, and e sub 1 equals, we have a 3 by 3 matrix. We have 1, 0, 1, 4, 0, 1, 6, 1 over 24, 0, 0, 1, 4. And this is the last step. And our answer for the inverse of a matrix using the elementary matrices is this, the 3 by 3 matrix, the product of e sub 4, e sub 3, e sub 2, and e sub 1. This is the inverse form of a matrix A. The answer for the number 23 is the inverse of A. This is the inverse form. We have a 3 by 3 matrix. We have 1, 0, 1, 4, 0, 1, 6, 1 over 24, 0, 0, 1, 4. To check if the answer is correct, we multiply the given matrix and our answer, which is the inverse matrix. The product must be identity matrix so that we can say that the inverse matrix is correct. This is our given matrix and the inverse matrix. We are going to use an online matrix calculator. We search the Reshish matrix calculator. And then we go to the matrix multiplication. We input the dimension of our given matrix. And we input the two matrices. And then we calculate this is our two given matrices, matrix A and B. And the solution. And the answer is the identity matrix. Based on what we got in the online matrix calculator, that given matrix times the inverse matrix is equal to the identity matrix. Therefore, our answer is correct. Thank you for listening. Again, I'm Carla Joyce Puno from the BSED Mathematics.